Good morning, everybody. Welcome back to the partial differential equation series. Today, I would like to continue with the another example of change of variables, which is a very interesting method in order to solve a partial differential equations. We're gonna explore the Black-Scholes equation today. It's really popular in physics and economics. Right. So the idea is, how do you reduce it? How do you reduce the Black-Scholes equation into a separable to PDE? I'll demonstrate it while writing. So what is the Black-Scholes equation? So what is a Black? Yeah, you have a double. Okay, I have to play them. Shown equation. So the Black-Scholes equation says something like this. It say the partial of v with respect to time, right, t, plus 1/2 s squared times the second partial derivative of v with respect to s plus s times the first partial derivative of v with respect to s minus v equal 0. Okay, so my proposal here is, so my goal right here is to reduce, let's call this 1. Let's call this 1. Reduce 1 into partial f over partial b equal a constant c times partial f second derivative of f, second partial derivative of f with respect to a squared. Okay, so you asked me, what is f, what is b, what is a? You just introduce it like that, which doesn't make any sense, right? So let me demonstrate. So that is the goal, that is what I want to, and this is the proposal. Okay, proposal. So what is the proposal? What can we do with 1? So we know that v is a function of s and t, right? Like based on the Black-Scholes equation. So my proposal, or our proposal, is so let v originally is a function of s and t. Let's say we can somehow convert it into a multiplication of functions. So let's say we can convert it into a function f as a function of a and b times g as a function of a and b. Okay, this is like an educated guess, or some article refer to this as ansatz, or my professor, he introduced the ansatz concept to me. It basically means educated guess. So what is FGAB? So now it's something interesting. So A is a function of S. Okay, so what does it mean? It means that if a is a function of s, then the first derivative of a with respect to s is not 0. So dA over ds is not 0, and you will have dA over dt equals 0. Okay. Similarly, you can say that I say that b is a function of t. So you can say dB over dt is not 0, and dB over ds equals 0. Okay, this is very important later, as you will see. And also that I will label this as 2, so we can go ahead and manipulate them. So let me recap for the like some sort of like introduction video for the Black-Scholes equation. So if you look at 1, this is the original Black-Scholes equations. Okay, through this video, I would like to reduce it into a separable PDE. First order, I'm not sure what's the correct term for this, but basically you can solve using a classic method. You can solve using separation of variable. Can solve using separation of variable. Okay, it's a classic method. One is kind of hard to do it, so I will attempt to reduce it into that form so that you can solve easier. And the proposal is just say that v, our main function, we split it into two functions, f and g. F and g is both a function of a and b. That's the first part. The second part is a is a function of s and b is a function of t only. A is a function of s only, so you have some sort of derivative relationship. And yeah, so in the next video we will do it step by step, and we can convert it. We'll start to convert from the V language to the F language, F and G language. So let me see. Next video, convert the V S T language into the F G A B language. So what it means is that we're gonna substitute it into some variables into one. You say we recalculate partial V with respect to T, with partial FG with respect to T, and then we can solve it in that language and we can do further. Okay, thank you so much for your attention, and I'll see you in the next video for a detailed step.